Thanks everyone for coming today. Today we're focusing our webinar on Bosch cameras and in particular their onboard analytics. I've titled this webinar Bosch Analytics at the Edge, a Step Ahead. And that's because from what I've seen as the onboard or on-camera analytics developed over the past couple of years, Bosch really seems to be a leader in that industry. Now we don't have a ton of experience with them. We've been connected with those guys for about 2 years now, maybe 3. But especially in the past year, we've got a number of demo systems deployed, and we've started, designing some systems around their technology, and I've been very impressed with what they can do. So we're just going to take a closer look at that and hopefully inspire some ideas in you guys like we've been. So for those of you who don't know me, my name is Michael McGuire. I'm the Vice President and General Manager of Stinson ITS. And for those of you who don't know who Stinson ITS is, we were formerly a division of Stinson Owlite. And Stinson Owlite's been a company in the traffic industry for about 60 years, very focused in traffic signs and devices, portable variable message signs. And I've been running the ITS division within that company for the past 6 years. And then as of January of this year, we broke off into our own separate corporate entity. And so we're laser focused on ITS. We have 13 employees across Canada. So we have people in Vancouver, in Calgary, in Quebec, and then we have 2 offices here in Vaughan. So we're very much more than what you see in the ITS industry typically, such as like a product distributor, just sell ITS focused solutions. Like we're very involved in projects from the design stage all the way through implementation and maintenance. So we do a ton of design consultation, integrating various systems together, providing that equipment, then kind of deploying the configurations, the integrations that we've designed, managing the projects the whole way along, and then also delivering long-term maintenance programs. So we're seeing a big move in the industry towards things as a service or things with very long maintenance warranties. So we have many contracts that are 5, 8, 10-year warranties. And so it's an interesting move, but it inspires better design. And so it suits our specialty very much so. So just a bit of disclaimer on, the goal of this webinar. So we are not an exclusive dealer of Bosch cameras. They are widely available from security distributors, etc. The real value that Stinson can bring to a project is our ability to design systems and integrate various components. And in that design process, a Bosch camera may or may not be involved. But that's what we do all day long, is solution engineering. And so these Bosch cameras have enabled some new applications that have typically been very expensive or very difficult to do. So this webinar is intended to be informational, kind of share with you what we've learned along the way, and give you, hopefully inspire you guys like we've been inspired by, what's possible now. So quick look at the agenda. We're going to start by talking about what are video analytics for those that aren't as familiar, a bit of a background on kind of where they came from and how they've evolved over the past 10, 15 years. And then the meat of the presentation is going to be looking at some interesting ITS applications. And we'll finish off with a quick live demo and then some questions. So in the right-hand bar of the webinar, there is a questions pane. So please, as questions come up along the way, throw your questions in there. And that way, when we get to the Q&A, there'll be a couple sitting there waiting. And keep in mind, it's going to be right before the live demo. We're going to have a quiz that's going to kind of just challenge you on some of the information we discussed earlier in the presentation. And so the winner of that quiz will get a little, bag of goodies sent to them from us. So keep an eye out for that. So what are video analytics? So I often take for granted, our knowledge in the industry and just assuming that the audience knows what I'm talking about. So I wanted to include this slide just to kind of simplify what we're talking about. And so video analytics is essentially the conversion of video streams into information. So maybe I should put my mouse over here. So the information can be a wide variety of things. In traffic, we typically see that information in the form of where objects are in an image, the detection of objects in the first place, and then the potential classifying or counting of those objects. So for like stop bar detection, we'll see a lot of video detection systems that say, is there an object in this zone? And if so, let me know so that I can place a call to the controller. Or in counting applications, they want to know, is this a vehicle? And if so, count it. And if it's something else, perhaps count that. So it's turning raw video data into information and then presenting that information into a database of some sort for later analysis. So a bit of background on kind of where analytics came from. So they very much started in the security industry. So CCTV has typically just been a security device that monitors typically a facility and provides, security alerts and companies the ability to record video and monitor live footage of their offices and stuff like that. And so when analytics were first developed, they were a little bit more simple, usually focused around movement. And because all systems were typically at a single facility, wired directly back to a single server, it made a lot of sense to deploy analytics at the server. And so because they're all centrally processed, they're all being recorded there, there's processing power available, that's where typically analytics were deployed. And kind of the big pros of that is lots of processing power available in a server, and streams are often recorded. So you can, process things after the fact on recorded video. Now, edge analytics is kind of the next step that we've seen in the last 10 years or so, is where that processing power, as cameras are starting to become distributed across wider networks, not just at a single facility, there's a need to do intelligence in remote areas. And when you're doing server-based analytics, the key part of it is that you have to be streaming live, high-quality video back to the server in order for it to run the analytics, because the analytics are only as good as the frame rate and the resolution that you're getting from the camera. So it put a lot of limitations on analytics that could be performed at a distance. And so edge analytics have been coming out to kind of address this problem. So you can place the processing out in the field with the camera, have it do that processing out in the field, and then all you have to send back is data, which is obviously a lot lower bandwidth. So that's the biggest advantage of edge-based analytics, is that it's lower bandwidth. But another one that seems to be less known is it's very pro-privacy. So because you're not recording the footage, because you're not streaming it, there's much less concerns around privacy. Often anytime you tell a customer that there's going to be video involved, there's a lot of policy questions around who gets access to it, how is it recorded, when is it recorded. And so by having the processing happening on the camera, not 24/7 recording, not even streaming that video, and having, certainly once you have it set up and you know the analytics are working properly, to have it only sending data is a very privacy-friendly approach to it. And you can also even set up intelligent video recording. So instead of recording constantly, you're looking for certain trigger conditions to initiate recording. And that way, at least you have taken steps to protect privacy, and that often helps with policy concerns and privacy issues. And so because we have this ability to deploy cameras with low bandwidth, that is typically deployed with LTE, cell modems. And so certainly in the traffic industry, that's what we see. A lot of traffic cabinets getting connected with LTE, and now also cameras and other devices like that can be deployed at low cost. And it opens up a couple opportunities where you typically wouldn't have the ability to sense in the way you are here, or detect and remotely notify on an LTE connection. And so you'll notice that when we start talking about applications, how that is relevant. So, and I should mention the one con is processing power. With edge analytics, inevitably you're limited to how much computer CPU you can get into the field, or GPU technically. And server-based is always going to be more than the field, but these camera processors are getting better and better every year. So when you talk about edge analytics, it's important to distinguish between kind of the two key kind of configurations we see. Edge analytics can be deployed with hardened PCs in the field. So you're kind of getting the best of both worlds. You're putting a camera in somewhere remote, but you're also putting the processing computer out there with it. And so it can do heavy duty processing, and it can be deployed with a low bandwidth connection and send just data back to the server. And a good example of that is MyoVision Traffic Link. So those of you who know Stinson ITS, we are a Canada-wide distributor for MyoVision, and we've been selling them for about 4 years now. And so in my experience, they are the best camera video detection system in the traffic industry, and they provide a good example of what heavy duty horsepower focused in on object identification and classification means in practice. So if you see in this little clip here, you can see differentiation between pedestrians within a crowd. And this is, if you're familiar with video detection at all, you understand just how difficult it is to detect crowds and distinguish crowds of pedestrians. So if I were to try to run something like this through a Bosch camera, this is a Bosch camera on the right, if I were to try to run it through there, it would just be one big blob thinking it's one or two pedestrians. So it takes the two big GPUs that are inside the MyoVision system here to crunch the video that's in there and really get high quality object detection. So that's an example of hardened PC processing. But what we're seeing the industry move towards is on-camera analytics. So reducing your infrastructure so you don't have multiple devices in the field. You have just the camera, and on the camera you have a decently sized processor. So the process sizing used to just be enough to be able to stream video, but now it's not only streaming, but you also want to do processing on there. And so the size of the microprocessors that are on cameras has been increasing. And so you're not anywhere close to what you would get with a hardened PC, but it's much easier to deploy a system when you have just a camera, because there's a lot less infrastructure, it's a lot more affordable and more simple to deploy. And so there's a number of big players in the industry. Bosch and Axis seem to be the leaders, at least as far as camera technology. As far as analytics, I'm only familiar with a few of the key brands. I'm sure there's some others out there, but among the top brands, Bosch is the best that I've seen. And this is an example of our demo system that we'll be jumping into later. It just shows you kind of the basic ability of the system to detect pedestrians, classify objects, and count them in a basic way. But a bit of a spoiler here, counting at an intersection like this is not well suited to a Bosch camera. We just happen to have a high-speed connection on this project and decided to put out a camera to do some testing of this Bosch analytics. But yeah, if you want to count at an intersection, I get a MyoVision. But there's some very key applications that we'll get into later that Bosch analytics are really well suited for. So just to look at how analytics are set up, and that's one of the big values of Bosch, is that it's kind of the good and the bad, because it's very customizable. So you can set up a wide variety of rules. Again, here it mentions 16 different video analytics rules, and 8 of them can be set in parallel. So you can be counting in 8 separate areas, or you can be looking for presence over here, counting over here, and it can all do it simultaneously. The challenge with that is that it takes a lot of experience in configuration to know how to tune those correctly and to set them up correctly. And so it's kind of a bit of a curse sometimes, because it's a bit too much information for some customers, because it can apply to such a variety of industries, not just traffic. Often it's difficult to know how to properly configure these zones to make them work and do what you want properly. But these analytics can run on either thermal or optical cameras. And you essentially, the process is to set up a rule, and then you can filter based on size, speed, directionality, color, or object classification. And that ensures that the rule is operating correctly and you reduce false calls as much as possible. And then at that point, you hopefully have good data, and that data is then ingested. It can be locally controlling something, but more often than not, it's remotely being sent to a VMS or an ATMS system. Bosch does have their own cloud as well for data ingestion and analysis. And systems like Genetec, support Bosch right out of the box. So if you want to view your speeds or your counts or data, it can pull right into Genetec and you create dashboards, etc. So this is just a quick look at what the Bosch interface looks like. You basically have the live stream. You can select the rule, and we'll get into this more at the live stream, but you select the rule, select some filtering, and then you just keep adding different tasks that you want to do, and you're off to the races. So kind of the meat that I wanted to talk to today in this webinar was focusing in on the cool ITS applications that are starting to become possible because of analytics like this. And certainly for me, we do a lot of consultation, like I mentioned, and customers will often come to us with challenges to say, I want to do this, how can I do it? And so we're often challenged to go and look for different creative ways to perform or solve a problem. And more often than ever before, we're coming across problems where Bosch and the analytics involved do have the opportunity to solve some of these challenging problems. So I'm going to just highlight 4 key problems that have been kind of very specifically solved. I shouldn't say solved, but addressed by Bosch. And we've designed a number of systems related to this, and we anticipated being quite successful in performing this. So the first is ped and cyclist counting. This has always been a challenge because radar is not very good at picking up those. And while systems like MyoVision and video detection systems at intersections are very good at counting these objects, they are very expensive. So if you want to count on a multi-use path, putting in a full-blown system like MyoVision is a bit pricey. So we see smaller, simpler cameras like a Bosch, a few $1,000s to perform the same task. And so we see an opportunity to deploy those sensors in that space. Custom warning systems, and I say classification is key, and that's because now that you can, like in analytics, being able to say there's an object here and it's in this box is one thing. That's kind of where it came from. But the real innovation now is to be able to say with a certain degree of confidence that that is a truck. And is there a truck inside that box, yes or no? Or that's a pedestrian or a bike, and is it over there? You can start triggering based on the what the object is, and that opens up a number of ped and truck activated systems. And highway monitoring, this is kind of the classic use for CCTV and traffic. And we've seen some basic analytics in the past, but I'll show you a video here from highway monitoring. This is not us directly, but I've seen some pretty compelling videos on how this is working, and I do know that's being used in the Canadian industry quite a bit. And finally, we're going to talk about the camera trainer. Now, I don't have a ton of experience with this one, but it is a pretty unique feature. This is essentially machine learning on the camera, being able to teach it what objects look like, and then it can recognize that going forward. And so it's kind of a cool feature I haven't seen from anybody else, and so I wanted to highlight that for you guys. So multi-use path counting. So this is where I think onboard camera analytics can do, a great job at detecting and tracking and counting peds and bikes. So like I said in the other screen, using onboard analytics for detecting large groups of vehicles or pedestrians is not well suited for onboard analytics. It's just too much information. It can't separate the objects very well. But something like a multi-use path, this is a picture of a system we designed recently where you have a single lane trail and you're just going to have individual bikes or people walking through that lane. Deploying a system in that scenario where you have just occasional traffic passing through, not massive groups of people, is very well suited for a Bosch camera for analytics. And so this is just an example of where I think the solution would be well suited. Another one is, like I mentioned, warning systems focused on pedestrians and cyclists. So this is one that we designed a few months ago where a customer had a rural highway on kind of a blind curve, and they had a number of conflict incidents, and I believe even a few collisions with pedestrians and cyclists and vehicles coming around that corner, not noticing them. And because they have a general store and some other commercial activity at the side of the road there's often peds and bikes driving up and down. So the concept here is detect them with a camera. We'd also have verification cameras to zoom in a little bit more and track those objects. The idea is recognize pedestrians and cyclists, and then wirelessly activate warning beacons on the 2 approaches so that vehicles know that pedestrians are ahead. This is just an overview of that blind curve. And so you had pedestrian traffic along the highway here and just very fast vehicles coming around the corner. So just a way to warn them. And it's not an easy way to detect pedestrians traditionally. So this was an interesting use case. Something similar here as well is truck detection. So in the past, truck detection has been somewhat of a challenge. The primary method is through overheight detection, but in certain scenarios like this one, you can't easily filter out for just the traffic you want to see. So this is a customer that was wanting to warn another blind curve with a small road that would enter on the curve. And so as trucks were pulling out, taking a left or a right from this exit, or trucks entering that road would block and potentially cause a hazard. There's a number of conflicting events between vehicles traveling down this main road and trucks turning in or out of that side road. And so while we could technically put an overheight system here and detect trucks that were exiting from that road, you wouldn't be able to detect trucks taking a left here because through traffic would detect that as well. So Bosch offered an interesting solution to be able to detect in both those zones economically and provide warning to the remote signs. So let me just jump to the next screen. So this is an overview. So what we decided to propose was a camera on a pole here, watching both of these zones, the left turning lane and the left and right turning lane from the side road with wireless connections out to these warning signs. And so we filter and say, is there a truck inside this zone or inside this zone? If so, activate an alarm, which is tied to a digital output on the camera, which then locally triggers these warning signs wirelessly. So now this is the third one that I've come across, and highway monitoring has been around for a long time. I just haven't seen it done very well. So the big advantage to Bosch, this is actually a picture. I didn't really get too much into the camera models, but this is Bosch's most popular one for traffic industries. It's they call it the MIC, the MIC. And so this has either an optical, a thermal, or both image sensors embedded in it, and just very good at the high resolution, 4K or better, and really powerful zoom. And the big key with this device is that it can very accurately PTZ around an image, and so much so that it can go back to the same point that you'll see analytics become activated as it jumps through its various prepositions. And so the value in a camera like this is you can do your basic monitoring of the roadway, and then periodically you can have the camera automatically jump around and inspect its surroundings to look for stopped vehicles or for other offending vehicles and send alerts accordingly, and then have it jump back to its normal monitoring operation. And so you can kind of get multiple purposes out of a single camera. And so I do know that the MTO has deployed quite a few of these. I keep seeing them pop up more and more at the side of the road, and a number of cities have these as well. But we are not involved in that testing. And the final one I wanted to talk about was the camera trainer. So this one's really cool, but again, we don't have a ton of experience with it, but it did come up recently, so I wanted to point it out. And what this allows you to do, if you're familiar with machine learning and computer vision, a lot of it's focused on training an algorithm to recognize certain objects based on characteristics of the image or of the object. And so the way it works is you teach the camera through feeding it positive or negative images on what a car looks like or what a car doesn't look like. And through the continuous training and feeding of those images, the algorithm starts to know what a car looks like and can then detect and track it automatically. And so usually that's all done on the back end by camera manufacturers, but there's a cool feature in Bosch cameras that keeps getting better and better, but it allows you to submit your own training images to a camera. So you can feed it positive or negative image of what you want it to detect, and it will slowly, after 30, 40, 50 images, however many it takes, to recognize the condition that you're trying to track. So the basic one that we've seen in their manuals focus on like security applications, like a gate. So teach it what a gate up condition looks like and what a gate down condition looks like. That way it can alert you or maybe just track how often the gate opens in a day. For us, this came up recently in a design request from a customer where they wanted to detect the up-down status of a lift bridge, and they wanted to do it very non-intrusively. They did not want to interface with the bridge itself or with the bridge authority. And so one of the solutions we suggested was to use the camera trainer, in this case on a thermal camera, just so that we have really bulletproof detection in all weather conditions. But if it was less mission critical, you could just use an optical camera. But we proposed putting out a camera nearby that had a reasonable view of the bridge and to train it on because it's such a significant change in the image of the camera, something like this is something that could be trained into the camera. And so again, we don't have a ton of experience with this, and I'm sure there's a million other applications that we haven't even thought of, but it just allows you to really focus in on niche applications. I've heard of guys using this to teach it what a FedEx truck looks like in DHL and UPS, so that if you're enforcing a curbside rule where you can only have delivery trucks stopping there, you can have it alert when a non-delivery truck stops at the curb. And so we've never done that, but there's, again, lots of applications that might be possible with this. And again, we're very focused on ITS, so we don't get involved in these other ones so much, but of course the analytics can be used for a lot of different stuff, smart parking for occupancy. You want to know how many spots are open, enforcing no parking zones. They do like enforcing no stopping zones for people, whether on highway or on arterial roads. They are used for wrong way traffic, although I typically see that with thermal cameras. Curbside management, like I mentioned, enforcing taxi only zones and things like that, and pedestrian detection. So we'll show you a bit of that as well, because counting pedestrians on a crosswalk is difficult with onboard analytics, but just knowing if there's one there or not, that is something they're quite good at. So we're going to jump now into the quiz. So I'm just going to pop up the question. And so in the right-hand corner, you have the the question box. If you can just post, there's going to be 4 possible answers, A, B, C, or D. If you can just post your answers into the question box, and the first person to answer correctly will be the winner, and we will send you out a little gift basket of products from Stinson Stinson ITS, including a pen, a notebook, and I believe a coffee mug. So here's the question. Edge analytics are typically deployed in 2 primary configurations. What are they? On camera and cloud enabled, server-based and hardened PC, on camera and hardened PC, or hardened PC and cloud-based? And Samantha will take a look. Oh, let me show you what you'll win if you get this. And then Sam, let me know once we have a winner, please.
So we already have a winner. Craig, you are the winner. The correct answer was C, on camera and hardened PC. Craig, I will contact you afterwards to get your shipping information. Congratulations.
Very nice. Congrats, Craig. So now we're going to jump into a quick live demo. So I'm going to kind of show you this system I've been kind of showing clips of throughout the program here. And I'll just give you a quick glimpse of how that works. We're a little tight on time, so we won't spend too much time there. But actually, it was funny because when I went to jump onto it before the meeting, it was showing camera unavailable, but I think that was just a momentary blip. So Configuration Manager is Bosch's software that you use for configuring analytics and calibrating the cameras, etc. So VCA is what they call their video computer analytics. So let's just show you an example of that intersection-based counting. So what I've set up here is, let me just turn to stream 2. It's a little lower res. It'll come in more smoothly. So what we have here is counting lines. So each of these ones with a triangle on it are vehicle counting zones. And you'll see it tracking pedestrians, vehicles, and as pedestrians cross these lines on the crosswalks, that's counting pedestrians. And so you're going to be counting vehicles on each approach, as well as pedestrians as they cross the crosswalk. Again, even if you see up here, it's grouping all these objects together. It will get a little bit better as it passes through the intersection. But really, the best application for a camera like this is to be on a dedicated roadway with just one road focused on. There's a bit too much going on here for this type of camera. So if I go into tasks, you can see how I configure these analytics. So I've got an analytic for each crosswalk, as well as one for each of the vehicles. So as I go into, adding a new analytic, you can choose object and field. So if an object is in a square over here, is that when you want an alarm? And then you need something else like Genetec or some other software to be able to react to that alarm. So what do you want it to do once a vehicle's in that zone? So you can have it trigger when an object's in a field, when an object crosses a line, when an object loiters in a field for a certain amount of time. It can be something related to parking. Some of these other rules are related to security, but they can be, creatively used for different ITS applications. But the other two that are very heavily used in traffic is counter. That's what these lines are. They provide a counting line plus a readout of what the count is. And then occupancy. So this is for like queue detection. So how many cars or how many objects are inside this box? So mostly queue detection or crowd size estimation is what you would use that for. But once you've selected an object, you can create, say, a new line, set this up somewhere on the view, select which direction you want it to count in, both directions or only one. This is setting limits. That doesn't really apply for us, but then you can filter. And adding filters to this line involve, I only want to count cars. So now it'll only count when it sees the car go through. Then you can filter by size. If you're finding there's false calls all the time because of, I don't know, some condition that happens where it's mistaking something as a car that really isn't, you can filter out by height, width, or area. I find with classification enabled and properly configured, this doesn't apply very much. But one filter I like to do is directionality. So if I'm filtering for cars traveling through this intersection, I can say I only want to count vehicles that are coming from the left side of the image and the right side of the image. So if a car passing north to south happens to change lanes or something as it passes through that zone, it's not going to count that. It's going to be very narrowly focused on objects that are primarily traveling in these directions. And you can also filter by speed. So if you want only objects traveling over, like of course speed's not going to be perfectly accurate in a video situation, but you can filter by that as well. Now I haven't really used this very much, but if you wanted to filter by color, if you wanted to detect only school buses or only yellow taxis, things like that, you could filter by the color of the object. And then you can do debalancing. So if if people are momentarily passing through a zone and you want it to trigger only when they're in the zone for a few seconds, then you put a bit of a debalance in there, say it must be in there for at least a few seconds or a few milliseconds. And that's it. Now we have a line across there, and this is the generic counter here, number 9. So if an object were to cross through there, it'd start counting. And that's what you're seeing here is as objects pass through these lines, they'll begin aggregating these different counts. So if I were to look at the east crosswalk, this one is designed with a bit of a debounce, but it's focused on upright people, and that's it, no other classifications. So I am not going to save those changes. So that's an example of this configuration, how that worked. And I can pull up another example. This is a PTZ camera. So I've set up another view with different analytics. So as you saw in the tasks there, you can have up to 8 different analytics enabled at the same time. In this case, I only have 2 enabled, and it's pet counting and pet presence. So this is kind of focused on an idea of, if you wanted to an extended green when the pet's in the crosswalk, or if this was, we're seeing this in crosswalks more often for PXOs that, using intelligence to tell when someone's present on the crosswalk and activate automatically or extend a light. So this is, I don't know that we're going to see anybody cross here, but I did have a little clip I took to show you what it would look like. Pull it up here. Let's just let it play for a moment. So you see in the bottom left here, somebody coming in, and if they're in the zone for more than 2 seconds, then they will trigger the presence zone. And the zone turning red is just an indication that the alarm is being triggered, and that information could be used by a system to react to that. So that's it for the analytics. Oh wow, look there, there's a nice conflict. So this is a construction zone, and these lanes are being shifted all the time. I wish we saw that a little sooner. Okay, So the final thing I wanted to show you guys is the zoom ability of these cameras. This MIC is quite impressive. So if you jump in on, I just did a zoom example. Just have it pull up here so you can see. Typical garbage bin, put organics in here. But when you start to see, let me change this to stream 2 so it's a little more quick. As you start to zoom out, you can kind of see just how far away these are, and your ability to zoom in and see details or a plate or something like that is quite impressive. And so you can imagine how this could be used on highways for, long distance monitoring of different areas. So let's jump back into the presentation. That's basically it. There was one video the Bosch guys shared with me yesterday that I was just going to pass along to you. And it was an example of counting in the kind of the angle I was telling you about. So this is footage they sent me where you're focusing on just a single approach. Instead of trying to watch all the vehicle traffic through an intersection, focus on only a single road, and it does seem to work a little bit better. In this case, they are detecting a bus as a unique object. That must be a new firmware because the camera I have out there doesn't do that. So anyways, that's it for today. So if you have any questions, please post them into the right-hand sidebar, and I'd be happy to answer them. Sam, if you can please read them out when you have a chance.
Yeah, so we do have some questions. And the first one was, are the Bosch Edge cameras power friendly, and are they able to be on a solar powered trailer for extended periods of time?
Yes, they are. It's going to depend on the model you get. So the analytics is available on cameras as cheap as around $1,500 for very basic non-PTZ kind of fixed dome cameras, up to PTZ mid-level, which is kind of the traditional access camera you'd see. And then what Bosch is really popular for is that MIC camera, which has no bubble, no dome. And that one has a very, strong motor in it. So that one's a little bit on the edge of what you'd put on a camera trailer, but certainly the mid to lower end models consume anywhere from about 7 to 14 watts of power. And so we've got a number of camera trailers using these cameras.
Someone asked, can you address the alert/output/option/formats or input/output triggers?
So for the output, there's a couple of options. There is an API or an XML feed that's continuously being generated by the cameras. And so if you want to do kind of a back-end API integration of a camera and develop your own software to monitor the status of a certain alarm field, then you can do that. We do that in some scenarios where we want to do more intelligent interactions with the system, automating, when something happens here, trigger a VMS sign up the street. That's what we would use that for. Alternatively, you can trigger locally via digital I/O. So there is output, like electrical output, local to the camera, and I believe you have to get a separate cable. And there's about typically 6 to 8 digital outputs available, which then can be locally wired to something to trigger wireless beacons to flash, or like a blankout sign to turn on. Like if you're detecting pedestrians at a crosswalk and you want to warn right turning traffic, you could have it trigger locally a blankout sign to pop on or something like that. As far as input triggers, I'm not sure what you're speaking to there, but if you want to send us a follow-up email, I'd be happy to clarify that a little bit more.
Can the data, counts, etc., be exported via cellular every minute or so? Can you get email, text, real-time alerts?
Yes and yes. The alerts and the emails is going to depend on the system that's receiving the data. And so Bosch has a cloud system. It does not have email alerting and everything built into it for count data, but more advanced systems like Genetec Security Center can do all of that. It can do any kind of alert that you want, as far as including like event action. So have multiple things happen before you're alerted. And as far as continuous data stream, yes, that API I mentioned that each camera is generating, that data stream is live And so not only, I didn't get into metadata in this presentation because it gets complicated, but there is a metadata stream where it's streaming a ton of information on everything inside the image that the camera is seeing. And from that, you can extract additional information beyond the analytics that you set up. So yes, the status of the analytics, it's on, off, or the presence or counting of an object does get updated. And there's a bunch of other metadata that's collected that can be used for that purpose and others as well.
Are these cameras suitable in colder environments? Does it classify vehicles like traffic counters? Can we use it for on-site condition assessment?
On-site condition assessments. Not sure what that's referring to, if it's like a weather type application. It is not suitable as a vehicle counter, kind of like a radar count station would be. Like you're not going to get reliable counts. That's when I focus the applications. I really think the remote trail and a bike and ped counting is really a strong suit. As you saw when I did the live demo, when you have high traffic or multiple lanes, there's a lot of obstructions that occur, and you're not going to get, first of all, reliable speed or classification data, but even the counts would not be all that great. So for a count station on the roadway, not so great. And I didn't quite understand the situational, like we use it for monitoring work zones and things like that, but I don't think that's what you're asking about. But again, please follow up via email. We'll send you a follow-up here with my contact information. I'd be happy to discuss it a little bit more with you.
What about colder environments?
Colder, yeah. So the cameras are rated to -40 and I believe +65. So they're all very much cold weather friendly and no problem there at all.
So that's the end of the questions.
Perfect. Thanks, everyone. The one thing I want to mention before we shut down here today is our next webinar, which is going to be on July 7th. And it's going to be focused on, I hope you guys have heard of this before, but I wouldn't be surprised if you haven't, the TC31A, which is an automated truck entrance and exit warning system. So my colleagues at Jay and Sherry will be talking about this. And this is a system that Stinson designed quite a few years ago. And this system is standardized and it's in book 15, but it's annoyingly is never used. So contractors seem to just be too cheap to want to put the money into deploying the system. So we see some very ghetto versions of this where it's supposed to be activated by a sensor, but they'll just put up cheap 24-hour beacons on the side and call that good enough. And there's no enforcement around these. So thankfully, we're starting to see an uptick in interest in these systems, and we're starting to deploy more and more. But they're going to talk about how the system works, what we see, the challenges in the industry as, and kind of where things are going from here. So I hope you'll join us next month for another 45-minute presentation. And yeah, thanks very much for joining us today, and we'll catch you next time. Bye-bye.